Recording in progress.
We'll start with the next problem. Integration of 0 to pi by 2 dx upon a square sin square x plus b square cos square x. Now see, if you apply that 0 to a property, sin will change to cos will change to sin. 0 to a property, f of a minus x. But then that will not have an impact. Okay. If you apply that property, the denominator will remain the same. The numerator will still remain dx or 1. So nothing can get cancelled if you add 1 and 2. If you apply that property 0 to a property, okay, right? So we'll rely on whatever we had learned in INDEF, right? Which is this type, constant upon a sin square plus b cos square.
Divide.
Okay, divide throughout by cos square x. Okay, so I ऊपर का 1 upon cos square x is sec square x, a square tan square x. Each term is getting divided by cos square x. Okay, each and every term. Now put tan x is equal to t. dy dx of tan x, dy dx of t, sec square x, dy dx, sec square x dx is dt. Now what is the value of t? T is tan x. What is x? 0 and pi by 2, right? So what will be t? 0 and not defined. You're going to put the value of x as 0 and x as 90 over here. Okay. So integration, this will be 0 to not defined dt upon a square t square plus b square. Now there is no middle term. There is no t term, which is the middle term. So you can group a and t. If there is a middle term, we'll have to eliminate a square. Right? 0 to infinity. 1 upon dt t whole square b dt. This is t, x and a. We'll name it x and a. 1 upon x square plus a square. 1 upon a tan inverse x by a. 0 to infinity. Okay. Now a is what? B. Tan inverse at by b upon. Now many students will forget this. dy dt of at. Because instead of t we are having at. Right? So of course don't forget this. What is the answer of this? What is the answer of this? A. A outside, no? A into 1. So this will be 1 upon AB. This will be 1 upon AB. Okay. Tan inverse at by b. Okay. This part is A. So A into B is AB.
So,
Yes.
how did you get that 1 prime B outside?
What is A?
B.
Put the value of A.
Integrate
आउटसाइड नहीं, वैल्यू तो डालना ही पड़ेगा ना ए का.
outside the bracket comes.
कांस्टेंट ना. That's why. 1 upon AB. Box minus box. Tan inverse A into infinity by B will be not defined. And tan inverse A into 0 by B will be 0. What is tan inverse not defined?
5 by
5 by 2. And what is tan inverse 0? 0. Clear? So this should be your final answer. This part is chain rule. Dy dt of at.
Why you're doing it?
T square plus A square. Who is T? 80.
8.
So
Oh,
chain rule. Clear? Question number 2, as in the next question. Integration of this was shared with you all earlier also before your exam. इसका solution I had just put it over the group. Tan x, root tan x plus root cot x. Okay. Now, quite important this is 0 to pi by 4 root sin x upon root cos x, root cos x upon root sin x. So integration 0 to pi by 4, take LCM, sin x plus cos x upon root sin x cos x. Sin x plus cos x upon root sin x. Now guys, sin x plus cos x is the derivative of what? This is the derivative of what? Go by trial and error.
cos x minus cos.
We'll take sin x minus cos x. I am just taking a guess. What is the derivative of sin? Cos. And what is the derivative of cos? So this will be plus. So my guess was correct. Even if you write cos x minus sin x, work it out, na? And check whether you're getting the derivative or not. Understood? Okay. So this will be put sin x minus cos x equal to t. Okay. So derivative of sin x minus cos x, derivative of t. What is sin x? Cos x. And what is cos x? Minus sin x. dt by dx. So cos x plus sin x dx is equal to dt. T is sin x minus cos x. X is 0. X is pi by 4, 9. Sin 0 minus cos 0. Minus 1. And sin 45 minus cos 45. 0. Clear? Right? So 0 will be replaced with 0. And pi by 4, sorry, 0 will be replaced with minus 1. And pi by 4 will be replaced with 0. Okay? So cos x plus sin x dx is dt upon root. Now try to understand this. Whenever such situation is there, you have to, and any guesses? What will you do? Square both sides. Sin x minus cos x the whole square, t square. 1 minus 2 sin x cos x is equal to t square. A plus b the whole square I have written. A plus b the whole square. A square plus b square minus 2ab. So what is sin x cos x? Directly, can you tell me what is sin x cos x?
T square minus 1.
1 minus t square by 2. 1 minus t square by 2. Okay. So down it is going to be root of 1 minus t square by 2. Root 2 outside. Root 2 outside. What is this? Sin inverse t. Clear? Sin inverse 0 is 0. Correct. What is sin inverse of -1? Minus sin inverse 1. First I did this. ITF. Root 2 sin inverse 1. And what is sin inverse 1? 90, which is pi by 2. So this is pi by root 2. No need to write pi by root 2. You can also keep it as it is. Root 2 upon 2 pi. Root 2 upon 2 pi. Okay, so see, next question. Zero to pi by 2 sin square x sin x plus cos x. Okay. Now here I'm going to apply that property 0 to a. Will you tell me why? Denominator will remain the same, but then what will happen to the numerator?
1.
Cos square x. And then when you merge, sin square plus cos square will be 1. So property application will be successful. Okay. Even while solving for any problem, if you're doing this property, after adding 1 and 2, if there are no cancellations, that means what? Property application is unsuccessful. Property can be applied, लेकिन उससे कुछ फायदा नहीं होगा. Fine. So you need to be quick enough if you do that. Use 0 to a f of x dx, 0 to a f of a minus x dx. X changes to a minus x. In our case, x will change to pi by 2 minus x. 0 to pi by 2. Sin square pi by 2 minus x. Sin pi by 2 minus x plus cos pi by 2 minus x dx. What is sin pi by 2 minus x? So this is cos x plus sin x. Interchange. Interchange the denominator, as in change the order. Now what you're going to do? Add 1 and 2. I plus I. Two I. So what about this? 1. Okay. Any guesses what to do after this?
So make it into tan x.
Put tan x by 2 is equal to t. That method. 1 upon a sin x plus b cos x plus c. So out of these three, any two terms or all three terms, we put tan x by 2 is equal to t. Right? Method is 100% right, but then I will avoid it because the coefficients are 1. So look at the shortcut. You can do that. Huh? Put tan x by 2 equal to t. You can do that. So 2i. Okay. Root 2. 1 by root 2 sin x. 1 by root 2 cos x. Clear? Multiply and divide by root 2. Now what is 1 by root 2? You can either write sin or cos. Right? You can either write sin or cos.
Let's make it sine 47 cos.
Sine pi by 4 cos x plus cos pi by 4. 1 second. I'll make this cos and this is cos and this is sine. Fine. You can also take sine. That's not a problem at all. Yeah. So cos 45 sin x plus sin 45 cos x. You can also write pi by 4. That's not a problem. 0 to pi by 2. 1 upon root 2, right? Outside. Cos a cos b plus sin a sin b. That is sin a cos b plus cos a sin b, which is equal to sin a plus b. Compound angle formula. Sin a cos b cos a sin b. Compound angle formula. What is 1 upon sin? Okay. 1 upon sin is cosec. Yeah, I took this 2 down. Integration of cosec minus cosec x cot x upon dy dx of x plus pi by 4. Clear? So minus 1 cosec pi by 4 x plus pi by 4 cot x plus pi by 4. This is the simplified part. 0 to pi by 2. Now this is also a task. I minus 1 upon 2 root 2 box minus box. Don't write in one step. Cosec pi by 2 plus pi by 4 cot pi by 2 plus pi by 4. And this will be cosec 0 plus pi by 4, which is pi by 4 into cot pi by 4. Clear? What is pi by 2 plus pi by 4? What is pi by 2 plus pi by 4? 3 pi by 4. And what is 3 pi by 4? 135. Clear? Cosec 45, cot 45. Right? Are you understanding this? Yes or no? Now cosec 135 is equal to 1 upon sin 135. Sin 90 plus 45. What is sin 90 plus 45? Cos 45. Cross method. 90 plus 45. What is cos 45? Going to be clear? Cot 135. Cot 135. I think 1 second, 1 second. Integration of cosec x dx is equal to log mod cosec x plus cot x. I went wrong with the formula. Okay. Right? So sorry for that. Really sorry. I took the derivative. It's not derivative. It's integration. Clear? Let's practice that. Yeah. 1 by 2 root 2. 1 by 2 root 2 log cosec x plus pi by 4 minus cot x plus pi by 4. Okay. Upon 1. Why upon 1? Why upon 1, guys?
So, okay.
Chain rule.
X plus pi plus 2.
Correct. Now what to do? 1 by 2 root 2. Same thing, box minus box. Okay. Log. Now directly I write pi by 4. Pi by 2 plus pi by 4 is 3 pi by 4. And what is 3 pi by 4? 135. Right? Yes or no? Minus cot 135. And this will be log N1 mod cosec. Bolo. 45. How 45? How pi by 4? 0 plus pi by 4. Correct. Minus cot 0 plus pi by 4. That is also 45. Okay. If we just calculated na sometime back. What is cosec 135? Root 2 minus cot 135 was what? We didn't calculate, no? So we calculate cot 135. 1 upon tan 135. Tan 90 plus 45. 90 is over here plus anti-clockwise. In this quadrant, your tan is negative. Y-axis. Because 90 is on the y-axis, tan changes to cot. So this is going to be minus 1. So this is minus 1 minus log. What is cosec 45? Root 2, right? And cot 45 is 1. Clear, everyone? So this will be 1 by 2 root 2. Okay. Log root 2 plus 1. Root 2 minus 1. Log A minus log B. Root 2 minus 1. Because cot 45 is 1, cosec 45 is root 2. So this is the final answer, okay? Yeah, you can stop over here. Next question.
Tan x by 2 allowance.
Okay. Next one.
So,
Sorry.
The size is
Yeah. Okay. Next problem. Okay, see, guys, you can try this at home. Or rather, I think we should solve this. Sorry. Integration 0 to pi by 2 sine square x. Now this time it is 1 plus sine x cos x. Huh? It is 1 plus sine x cos x. Okay. Equation number 1. Use 0 to a property. Okay. What will be I? Anyone directly can you tell me what will be I? Cos x into sin x can be written as sin x into cos x, right? So we are not writing that in total, all the steps in between. But then I hope everybody understood this property application. 0 to a. Now, why I took a chance in applying the property?
So because the denominator stays same.
That is one reason, but in numerator we can manipulate, na? Sin square plus cos square 1. Property application is successful. Fine.
So
Add 1 and 2. Wait. 2i. 0 to pi by 2. 1 upon 1 plus sin x cos x dx. Yeah. This also in shortcut I have written. The final step after adding 1 and 2. Yeah, please ask. You were asking something, sorry.
so in this you said that sometimes this will be able to apply it, but it won't do anything.
Hmm.
So it, like what sense did you make that? Can you, like give an example?
Here we were able to add sin square plus cos square, no?
Yeah.
Were we able to add?
Yeah.
The numerator got changed. Sometimes it will not change.
So that
Property application does not make any sense. Numerator has to change. Some cancellation, addition, subtraction, something has to happen. By any method, nahi. After application of the property.
yeah.
Okay, now see everyone. Now this is not like the previous problem. We are having 1 plus sin x cos x. Now there is no specific method for this. Again, we have to try, we have to think something. So this is one way of understanding. Divided by cos square x. Let us see what is the net effect. What is 1 upon cos square x? Sec square x. 1 upon cos square x? Sec square x. What is sin upon cos square?
Tan
Tan x. So somewhat is it is successful. What is the derivative of tan? The derivative of tan is x square x. But then I'll change this also. I'll change sec square x to 1 plus tan square x. Okay. And then after that, after simplification, I'm going to put tan x is equal to t. Okay.
So-
Now I've given you the guideline.
But how does changing sex square x down?
Huh?
How does changing sex square? Oh,
We can take
because
tan
we
x.
get sex square x dx in the MOS.
Correct. So it needed to wear MOS.
Yeah.
I hope you're understanding because some steps are not written in between. Those are the easy steps. Now put tan x is equal to t. Okay. So these steps also I will not just write everything. So lower limit tan 0 is 0, tan 90 is not defined. Sec square x dx is dt. So this will be t square plus t plus 1, right? This will be t square plus t plus 1. How it became 0 to infinity?
Changing out.
Changing of limits because it is definite integrals. T is equal to tan x. X equal to 0, x equal to 90. Tan 0 is 0. Tan 90 is not defined. Okay. Half into coefficient of t. What is the coefficient of t? So half square. Don't write 1 by 4.
T minus 1. Most way.
Plus half square plus 1
T
Minus
plus
half.
minus half square dt. First three terms. What about the first three terms?
T plus half square.
T plus half whole square. Last two terms. 1 minus 1 by 4 is what? What is 1 minus
3
1
by
by 4?
3 by.
3 by 4.
Go on, sir.
Yeah. Clear? See, why we are doing this kind of problems is to enable you to think in different ways. Okay? If something abruptly appears, anything which is quite difficult. So you can think in different directions. root 3 by 2 the whole square, x and a. So 2i, 1 upon a, x by, what is a?
Root 3 by 2.
Root 3 by 2. Tan inverse t plus half root 3 by 2. dy dt of t plus half is 1. dy dt of t plus half is 1. Two by root 3. 2 will get cancelled. Tan inverse 2t plus 1 by root 3. Okay. Yes or no? Fine. Now what, guys?
So box
Box minus box. Tan inverse of 2 into infinity plus 1. So this will be not defined. And tan inverse of 2 into 0. 0 plus 1, 1 upon. Okay. 5 by 2, not tan not defined. Tan inverse not defined is 5 by 2. Tan inverse 1 by root 3. What is tan inverse 1 by root 3? 5 by 6. 5 by 6. Okay. So take LCM.
3 5 by
3 pi by 6. And root 3. What is 3 by root 3? Yeah. Yes or no? Hmm? 2 pi by 6. चलेगा. Not a problem. Sorry. 5 by 3 root 3. 5 by 3 root 3. Okay. Next one. Bapat. Bapat. We are booked to Ahuja. Today's part. Quickly go through. समझ में आ गया मुझे. Yeah. Next problem. 0 to pi by 2. X upon sin x plus cos x. Now you people tell me, will property application make sense? Have you applied the property to take that? Directly कैसा you people we get the same denominator, agreed, but then what about the numerator? Pi by 2 minus x, and when we merge x will get cancelled.
Oh yeah.
Okay, so without applying, you cannot decide it is useful or not. Make use of the rough work. Okay, but then that too very quickly. Do 0 to a f of n dx property. Okay. I'm not writing all the steps. Equation number 2. Clear? Add 1 and 2. Add 1 and 2. So I will be something like this. And sometime back only we have done this case. Okay, so we are not resolving this. Two methods over here. What are the two methods over here? Put tan x by 2 equal to t. Otherwise, multiply and divide by root 2. Multiply and divide by root 2. Okay. So see, look at this problem. Property application made sense. It should make sense. How do we decide it is making sense or not? Something gets cancelled. Of course, the denominator should remain the same. Correct?
So what was the first step, sir, of this? Second one was divide and multiply by root. First one is what?
Put tan x by 2 equal to t. That in the last
Three.
exercise, yeah. Okay, question number 17. Sorry, the next question. Integration 0 to pi by 2 log 4 plus 3 sin x 4 plus 3 cos x dx. I am giving you the hint. Apply the property, then add 1 and 2. Start. Apply the property 0 to a, then add 1 and 2. Please start. Apply the property, then add 1 and 2. Are you getting different equation number 2 after application of the property?
0. That's all. You can't do plus the balance thing if you separate this. That's what multiply.
Add 1 and 2. And when you add, you have to merge. After merging, do log a plus log b. What is log a plus log b? Log ab. And that will lead up to 1. Log 1 is 0. So when you add 1 and 2, 2i, when you merge, add this to, as in apply the addition property. Log a plus log b is log ab. So this is going to be log a into b. 4 plus 3 sin x. 4 plus 3 cos x into
0.
correct. So cancel is going to be 1 and log 1 is 0. Log 1 is 0. Okay. Next question. Integration -1 to 1. Log 2 minus x upon 2 plus x. Minus a to a. What should strike to you in the first place? Minus a to a. Even and odd function. We need to test. Minus a to a. Same value. -2 to 2, -3 to 3. So what is f of x? Log 2 minus x, log 2 plus x. So what is f of minus x? We are checking even order. 2 minus minus x. 2 plus minus x. Okay. So this is log 2 plus x. 2 minus x.
I didn't get it. What are you doing?
Even and odd functions. Whenever it is minus a to a, we need to check for even and odd functions. So we have started our check. This is f of x. We need to find out f of minus x. What is f of minus x? Replace x with minus x. So we arrived at this point. Is this related to f of x, guys? Is this related to this, or it is exactly the reverse within the bracket? Within the bracket, it is reverse. The numerator became denominator, denominator became numerator. Now see, everyone over here, I'm sending the numerator up and denominator down. So will be the power minus 1. A upon b is equal to b upon a raised to minus 1. Correct? Yes or no? Log a raised to b is log a. Log a raised to b is b log a. Now what is this, guys? What is this? This is f of x. So this is minus f of x. And if f of minus x is minus f of x, then function is odd. I equal to 0. Whenever the function is odd, I equal to 0.
So is it even?
Even then some other formula is there that will do.
So in your recordings, all are odd only the examples which you
Yeah.
give.
Yeah.
You usually get odd, isn't it?
Not necessary.
So when it's even order.
Even normally also you can solve without applying even ka property. Okay.
It's minus minus f of x is equal to f of x.
This without this minus sign, it will be even. So if it is even, solve normally. Normally, as in no need to apply that even ka property. Okay.
So how do you know if it's odd or even?
F of minus x is minus f of x.
That's the format.
It is odd. And f of minus x
F of
is equal to f of x. F of x is
even.
even. Okay. And when it is even, no need to apply that even ka formula which I have given. You can solve normally, like whatever procedure is there, you can apply different ways of solving the problem. You can do that.
But you do this only when it's
Minus a to a. Yeah. Minus 1 to 1, minus 2 to 2. That way. Okay. Clear, everyone?
So we have to do it to one.
Huh? Huh. Okay, now see, modulus problems now they behave a bit differently. And we need to solve it as per the intervals, the upper limit and the lower limit. So we'll take some modulus problems, okay? Integration. Okay. Minus pi by 2 to pi by 2. Sine of modulus of x dx. Sine of modulus of x dx. Now, of course, it is minus a to a, but then I will not go into even order because there is modulus in the problem. Don't go ahead with even and odd. Now, where is minus pi by 2 to pi by 2? This is 0. This is pi by 2. Minus pi by 2. So, where is minus pi by 2 to pi by 2? From here to here. First and fourth quadrant. Did you understand? What are this?
All positive. Only
Okay. What are this? Upper limit and lower limit. Upper limit and lower limit of what? Of which term?
Sin
X. We are integrating with respect to x now. So this is the upper limit and lower limit of x. X values this are. So x values will lie where? Between minus pi by 2 and pi by 2. But then we are going to break down this interval into two parts. बाद में doubt रहेगा. We are going to break down this into two parts. X lies between 0 to pi by 2. Okay. This is first interval, first quadrant. And X lies between minus pi by 2 to 0. The fourth quarter. So here what are the values of x? X is positive. And here what are the values of x?
Negative.
Negative. Did you understand? Ask if you're having any doubts, please ask. The entire interval I'm splitting into two parts. First quadrant and the fourth quadrant, minus pi by 2 to pi by 2. So first quadrant, 0 to pi by 2. These are the values of x. So when I say x lies between 0 to pi by 2, x values are positive. And when it is minus pi by 2 to 0, x values are negative. Right? Clear now? Okay. So now see. Same integral I'm going to break into two parts. 0 to pi by 2. Sine modulus of x will be written as plus x or minus x. Plus x or minus x.
Yes.
Plus x. Why? Between 0 to pi by 2 it is positive. Clear? And from minus pi by 2 to 0. Plus x or minus x?
Minus x.
Because
Only more like
x values are negative. Clear? Guys, are you understanding the? Okay. What is sin x, guys? What is sin x? Sin x. Sine of positive x is sin x. And what is sine of negative x? So that minus I will take outside. Okay. Minus pi by 2 to 0. Now don't cancel both, sine minus sine 0. Why?
So you have to integrate.
The limits are different.
Fine problem.
The limits are different. Now integrate upper limit, lower limit. Okay. Cos x 0 to pi by 2. Cos x minus pi by 2 to 0. Now solve this, guys. Come on. What is pi by 2? What is pi by 2?
90.
90.
Cos pi by 2 is 0. Sin pi by 2 is negative. So the negative, it's negative cos. You know,
Sine is negative cos. Sorry, I made a error in the formula. I'm applying derivatives formula today. I don't know why. Okay. So this is minus cos outside 0 to pi by 2 plus
cos
cos
0 minus pi by 2.
minus pi by 2 to 0. So minus box minus box plus box minus box. Start. Cos 90, cos 0, cos 0, cos minus 90. Clear, everyone?
This one.
Cos 90 is what? 0. Cos 0 is 1. Cos 0 is 1. Hey, what is cos minus 90? Is it cos 90? Cos minus x is cos x.
Yeah.
So cos 90 is what?
0.
0. So this will be 0 only. Clear? So the answer is 1 plus 1, which is equal to 2. I hope you understood this. Clear? Now there is a slight variation in the next two problems. Slight variation in the next two problems. Guys, you're clear with this? Now, before I start the next problem, I just want to ask you, where is the modulus in the problem over here? Modulus is for x. Now, the next set of problems, The modulus will be for the entire trigonometric function. Be very focused. These are two different things. Okay. So the next question over here. Okay. 0 to 2 pi sin x dx. Now modulus is not for x. It is for the entire trigonometric function. Because modulus के अंदर वो trigonometric function है. Right? Okay. Now let us understand this particular upper limit to lower limit. The entire domain will understand. 0 to 2 pi. Okay. 0, one complete round over here. Will it be 2 pi? Correct? So what is this value? Sin x. Now sin x value lies between 0 to 2 pi. Everyone over here. Now these two quadrants will behave differently. And these two quadrants will behave differently. Why you people tell me? Because sin x in the first and the second quadrant is positive. So sin x, I'm not saying x, I'm saying sin x. Why I'm saying sin x? The modulus is for sin x. The session is recorded. You have to watch this later on also if you want. 0 to 1. 0 to 180. Good. So here sin x is positive. Okay. Sin x is positive meaning what? Plus sin x. Now pi to 2 pi. Now pi to 2 pi. Sin x is negative. This is minus sign. Here. So this problem will be broken down into two parts.
0 to pi.
0 to pi plus sin x. And pi to 2 pi minus sin x dx. So this is 0 to pi. What is pi, guys? 180. Okay. Sin 180 is what? Calci is there for that.
But it becomes cos.
Ah.
0.
Okay.
So
Done.
isn't it minus?
Yeah. Have I written something wrong?
Like isn't the domain like just have to pi by 2 for sine? Like
No, but then we are supposed to consider this part 0 to pi, 2 pi. Okay?
so it doesn't that go out?
No. Guys, are you solving this?
Yeah, once
Please solve. Because any which ways pi is out of domain. Sin pi 180. And 1 equals 0. There is no value now for sin 180. What is the answer? Has anyone calculated?
no cos 180 is cos 360 also. Who is the mistake? 180 0 316 is 1 minus 1 0 equals to 1.
Guys, what is the answer? Has anyone tried this further? Answer?
-2.
Answer is wrong. It's not 0. It's not -2. Answer is 4. Okay.
So, again, like if you take the domain of and then want the thing change to like 0 to pi by 2 and then minus pi by 2 to
We
0.
are taking periodicity. It's 0 to 2 pi.
But like how?
Wait, now it's required. Just tell me. I'll address them. Next problem. 0 to 2 pi. Modulus of cos x dx. Okay. Now modulus is for the entire trigonometric function 0 to 2 pi. From 0 to 2 pi. One full round. Okay. Cos is positive in the first and the fourth one.
Yeah.
And it is negative from the second to second and third. Okay. Now see, there will be 3 parts because there is a break in between. Now directly I'm going to write, see, everyone. From 0 to 90. What is cos x? Positive. Okay. Now from year to year, it is complete negative. Pi by 2 to 3 pi by 2. It is negative. And then from 3 pi by 2 to 2 pi. It is positive. Okay. Did you understand this? Okay. Now see. The limits, the lower limit is from 0 to 2 pi. Okay. From year to year. Right? Now this is, we don't have to give importance to x. We have to give importance to cos x. Because modulus is for cos x. Now cos x is positive where? First and the fourth quadrant. Red ticks. And cos is negative where? Second and the third quadrant. So when I start from the first quadrant and when I enter over here, okay, the next value is going to be negative now. So there is a break. So from 0 to 90 it is positive. 90 to 270. 270 is 3 pi by 2. It is negative. And then what? Lastly, 3 pi by 2 to 2 pi. It is positive. So this part is self-study.
So, with tan will be 4 parts.
Hmm.
With tan is mod of tan x. It'll be full span
Hmm, hmm,
4 parts.
Correct. Because every quadrant there is a break.
Yeah.
So, this one. Okay, let him copy this. I'll just solve that.
So, is this
Try. Seems to be right. But then limits are not, you're not supposed to take negative values in the upper limit and the lower limit.
then you switch it and
Thoda sa, it will be a gray area. Still, it is going to be negative now.
yeah.
This one.
2
Oh, this is
-1.
0.
लिमिट ही गलत किया तुमने Yeah. Yeah. Okay.
I took this.
Next problem. One more modulus problem. Integration -1 to 1 e raised to modulus of x dx. Okay. one more modulus problem. E raised to modulus of x dx. Right? Clear?
So odd even.
Will not give preference to odd even because of modulus. Because of modulus, okay?
So there's modulus you want to.
Okay. Now modulus is for which term? X. So x lies between -1 to 1. Right? But then on a number line 0, -1, 1. X value is changing now from negative to positive.
Yeah.
Where? At 0. So there are two parts,
-1 to 0.
-1 to 0 and 0 to 1. From -1 to 0, x is positive x. Oh, sorry. X is negative x. Okay. And from 0 to 1, it is positive x. Integration -1 to 1 e raised to I have to take the limits. Yeah. Now positive modulus of x is written as negative x. And from 0 to 1, modulus of x is written as positive x. What is the integration of e raised to minus x? Minus e raised to minus x. 0 and -1. E raised to x is e raised to x. 0 and 1. Is this -1 upon e raised to x?
Yeah.
Yeah. Solve this and tell me what is the answer.
Just but so this is like an easily integrated. You can easily integrate it.
So no, without modulus, so don't even do even odd.
Yeah.
Simple probabilities, yeah. Correct, no? 2.
We don't need this to. I'm just going to believe.
It was you want them?
Yeah.
Oh, it's 1. I took it as 0.
The answer is 2e minus 2. The answer is 2e minus 2.
What is the cosine sum answer?
Okay.
Yeah. These two guys are small.
Okay. Yes, so you can simplify this, you'll get the answer. Next question. Okay. What is your suggestion over here?
So
F of x square 1 plus 5 raised to x. F of minus x.
-x square.
F of minus x is what?
X square upon 1 plus 5 is to -x.
Okay. X square. Sorry.
Yeah.
Minus x square. 1 plus 5. So x square 1 plus 1 upon 5 raised to x.
5 is to 4.
So x square 5 raised to x upon 1 plus 5 raised to x, right? Yes or no?
Yeah. Okay.
Now compare these two values. Is it even or is it odd? Or it is nothing? Huh? It is nothing.
Because there's no
We cannot compare, no? F of x equal to f of minus x or f of minus x is minus f of x. Nothing we are getting over here. Okay. So this is useless over here.
So done.
Okay.
Now what?
Now what? We have to solve this, no? Okay, now this is a commit to memory kind of a problem. Okay, so you have to commit to your memory. So use a to b f of x dx, a to b f of a plus b minus x dx. This is also a valid property. X changes to A plus B minus X. Now, if you ask me, how do we come to know that we have to apply this property? Disclaimer I have given right at the beginning. Commit to memory. Okay. A plus B minus X. A plus B minus X. Okay. So X will get replaced with minus X. Wherever there is X, we'll have minus X. Okay. A क्या है बता?
A is -2.
B क्या है? 2. This is A and this is B ना? नहीं समझा क्या? Both are getting cancelled. Minus X. Right? So this is 1 integration -2 to 2 minus X the whole square 1 plus 5 into minus X. Right? Wherever there is X, put minus X. In this property also, what do we do?
The same thing.
Add 1 and 2. But then we have not arrived at 2.
Yeah.
We have not arrived at 2.
X square 5x upon 5.
X square 5 raised to X upon 1 plus 5 raised to X after taking the LCM and all. Equation number 2. Equation number 2.
The thing is getting cancelled.
Huh?
The thing is getting cancelled.
So this one
Add 1 and 2. So 2i minus 2 to 2 x square 1 plus 5 raised to X dx plus minus 2 to 2 x square 5 raised to X 1 plus 5 raised to X. I'm going to merge this. I'm going to merge. Why are we merging? Okay. We are merging. One second. I think we got cracked. I'll just quickly write this. You people might have copied till certain number of steps. This was one using that property. You got this. Add 1 and 2. You got this na earlier. And after merging, you got this, right? Now, if you take x square common, if you take x square common, 1 plus 5 raised to X, 1 plus 5 raised to X. Anything is getting cancelled.
Yeah, 1 plus 5. So
1 plus 5 raised to X is getting cancelled. Acha, now see, you can directly integrate this. Everyone, you can directly integrate this. Otherwise, if you want, you can also apply even odd over here. So I'll explain how even odd works over here. Fine. I said na, you can directly do. Okay, but then some people wanted to know certain things about even odd. So let's do even odd. Fine. What is f of x? Why are we doing even odd at this point? Minus a to a. Minus a to a. Right at the beginning, even odd didn't work. What is f of minus x? X square. Hey guys, tell me what is f of minus x? What is f of minus x? F of x. When f of minus x is f of x, f of x is even. Now see how the property applies. This is 2i, no change over here. This is even function. 2 will come over here by default. Don't ask me how. Okay, for even 2 comes over here, 0 over here. A is what? 2. What are the changes happening? Whenever it is even, this 2 by default are not any other number. 2, what will be the lower limit? 0. And then solve this normally.
Wait, so can you explain the thing when you say after f of x is even then?
Whenever it is even, this right hand side,
Yeah.
we were testing over here,
Yeah.
this will change to 0.
Okay.
And here there will be 2. Fine?
Second one was washroom.
Recording में आ जाएगा ये सब. 0 and 2. Right? So 2 by 3 x cube. Okay. So this is 16 by 3, right now? How 8 by 3? This is 2i, sorry. So 8 by 3. Clear? Because this 2 and 2 got cancelled. Right? So this was the last problem of definite integrals today. Okay. Now just wait for some time. I'll think what more I can cover up.